Hello everyone. If you think you can solve this, pause the video now and share your answer in the comments below. Before solving this problem, let's cover the basic first. So today we'll learn about cyclicity of unit digits. Suppose there is a series, say A, B, C, D, E, again A, B, C, D and E and so on. Now it's asked what will be the 27th term of this series. So here you see that the series is repeating itself after every 5 terms, right? Hence we can say that the cyclicity of this series is of 5 and the digits of the cycle are A, B, C, D and E, right? So to find the 27th term, since the cyclicity is 5, we will divide 27 by 5. The remainder we get is 2, which means that the second term of the cycle will be the answer. So what is the second term of the cycle? The second term of the cycle, here this is a cycle, the second term of the cycle is B. So the answer is B. Now let's say that we have to find 114th term. Again, we know that this is having a cyclicity of 5. So the remainder we get is 4. Now this time the fourth term will be the answer. So the fourth term is D. So D is the answer. Say we have to find 285th term. Now what we will do again, 285 divided by 5. Here the remainder we get is 0. Now if the remainder is 0, it is not the first term of the series, of the cycle, but the last term of the cycle, which is E, is the answer. So 285th term is E. There is another question given like this: 7, 8, 9 into 2, 8, 4 into 3, 8, 5 and asked what will be the digit at its units place. So do we need to multiply the entire number? No. Multiplying the digits at the units place will give us the answer. So what we'll do, we will take the digits at the units place and multiply them. So we can write it as 9 into 4 into 5. Now 9 into 4 is 36. We don't even need 3, we just need 6 into 5 and we will get 30. So at the units place we get is 0. So the number is 0 at the units place. Let's take another example. 287 multiplied by 231 multiplied by 154 multiplied by 333. All we have to do is take the number at the units place and multiply them. So 7 into 1 into 4 into 3. So we can write it as 7 into 4 is at 12. We take 2, 7 to the 14. So 4 is the digit at the units place. Now again, let us find out take one more example. 287 multiplied by 354 multiplied by 289 multiplied by 590. Again, here the units place of this expression is asked. Now we see that at the units place we have a 0. So anything multiplied by 0 is always 0. Hence the answer is 0. Now let us see cyclicity of units digit in power. Cyclicity of units digit in power. Let us see the cycle of 2. So we can write it as 2n. Now 2n can be written as 2 to the power 1, which gives us 2, 2 to the power 2, which gives us 4, 2 to the power 3, which gives us 8, 2 to the power 4, which gives us 16. So we can write 6 as 6 is at the units place. Now again 2 to the power 5, again 16 multiplied by 2 is 32. So 2 to the power 6, 32 multiplied by 2 is 64. So we can write 4, 2 to the power 7, 64 multiplied by 2 is 128. So at unit place we get 8, 2 to the power 8 is 128 multiplied by 2, which is 256. So we can write as 6. Now again 2 to the power 9 is 256 multiplied by 2, which is 512. So we can write it as 2. So what we can see, after 2486, the value is repeating itself, right? So let's forget about this. So we know that 2 follows the cyclicity of 4 and the digits of the cycle are 2, 4, 8 and 6. So can we write it as 2 follows the cyclicity 4 and the digits of the cycle are 2, 4, 8 and 6. Now let's take one example. Suppose it's given 2 to the power 43 and the unit digit of this expression is asked. So what are we going to do? We'll say 2 to the power 43 and divide it by 4 because the cyclicity of 2 is 4. The remainder we get is 3. So we can write it as 2 to the power 3. Now we know 2 to the power 3. That means the third term of the cycle. So the third term of the cycle is 8. So the answer is 8. Similarly, 2 to the power 149. What will be the value at the units digit? We just need to divide the last 2 digit of the number by 4 to see if the number is perfectly divisible by 4 or not, or what will be the remainder. So 49 divided by 4, we get the remainder as 1, which means first term of the cycle, which is equals to first term is 2. So when we get remainder as 1, we can also write it as 2 to the power 1, which is 2. Now let's say 2 to the power 500. Again, we just need to divide the last two terms. So last two term is 0. So we know that it is perfectly divisible by 4. So remainder is 0. Hence, the last term of the cycle. So the last term of the cycle is 6. We can also write it as 2 to the power 6. Sorry, last term of the cycle 2 to the power 4. And we know that the last term of the cycle is 6. So the answer will be 6. Say if you don't know what is the value of 2 to the power 4? You can also write it as 2 to the power 2 multiplied by 2 to the power 2. Now 2 to the power 2 is 4 into 4. The unit digit that you get is 6. Now let's see one more question. It said that uh, 82 to power 150, what is the digit at its unit place? So we have nothing to do with this value. All we are concerned about is the digit at the units place. So the digit is 2. So we can write this as 2 to the power 150. We know that the cyclicity of 2 is 4. So we can write it as 150 by 4. We need to divide the last two digits to see what will be the remainder of 150. So we know the remainder will be 2. So we can write it as 2 to the power 2, which means the second term of the cycle, which is 4, and 2 to the power is 4 as well. So the answer will be 4. Similarly, take one more question. Say 278242 to the power 1, 2, 3, 4. We have nothing to do with these digits. What matters to us is what is at the units place. So at units place it is 2. So we can write it as 2 to the power 1, 2, 3, 4. Now 2 follows cyclicity of 4. So divide it by 4. You get remainder as 2. So you can write it as 2 to the power 2. That means the second term of the cycle answer is 4 again. Now let us see the cyclicity of 3. So we can write it as, or say 3 to the power n. Okay. So we can write it as 3 to the power 1 equals 3. 3 to the power 2 equals 9. 3 to the power 3 equals 9 to the 27. So at units place we get 7. 3 to the power 4, 7 3 is 21. So at units place we get 1. 3 to the power 5. So 3 into 1 again is 3. 3 to the power 6. Again 3 into 3 is 9. 3 to the power 7. 9 3 is 27. So at units place we get 7, and so on. So we see that 3 follows the cyclicity of 4 again. And the digits of the cycle are 3, 9, 7, 1. So we can write it as cycle of 4, and the digits of the cycle are 3, 9, 7, and 1. So let's say 3 to the power 67 is given. What will be the value of this expression at its units place? So we can write it as 3 to power 67 by 4. 67 by 4, remainder will be 3. So we can write it 3 to the power 3. So this means third term of the cycle. So the third term of the cycle is 7. So we can say 7. Take another example. 3 to power 118. So we can write it as 3118 by 4. Last two digit 4 for the 16. We get remainder as 2. So we can write it as 3 to the power 2. Now 3 to the power 2 means second term of the cycle. Second term of the cycle is 9. We also know that 3 square is 9. So answer is 9. Now take one more example. 3 to the power 260. Now we know that 260 divided by 4, the remainder is 0. So if the remainder is 0, it means the last term of the cycle. So we can also write it as, since it follows a cyclicity of 4, 3 to the power 4. This means the last term of the cycle. So the last term of the cycle is 1. If you don't know 3 to the power 4, you can also write it like this: 3 to the power 2 multiplied by 3 to the power 2. Now you know that 3 square is 9. So 9 into 9 is 81. So hence 1. Now let's see cycle of 4, or 4 to the power n. So 4 to the power 1 equals 4. 4 to the power 2 equals 6. 4 to the power 3 equals 6 4s are 24. So 4 again. 4 to the power 4. So 4 4s are 16. 6 again, and so on. So we see here that 4 follows the cycle of 2, right? And the digits of the cycle are 4 and 6. So we can write cycle of 2, and the digits are 4 and 6. If you see here, we see another pattern, okay? That 4 to the power odd is always 4, and 4 to the power 6, so sorry, 4 to the power even is always 6. So we can also say that 4 to the power odd will always be 4, and 4 to the power even will always be 6. Now let's see one example. Say 284 to the power 586. What will be the value of its units place? Now we know that it follows a cyclicity of 2. So what we can do, either we can divide, we can write it like this 4 to the power 586 and divided by 2, remainder is 0. Hence the last term of the cycle, the last of the cycle is 6. Hence we can say that 6 is the answer. Alternatively, we can also say that we have 4 to the power an even number, and 4 to the power of even number is always 6. Say another question: 5 8 3 2 4 to the power 8 7 3. What will the value of this expression at its unit place? So we can write it as 4 to the power 8 7 3. Now the power is odd, so 4 to power odd is always 4. Hence 4 is the answer. Alternatively, since it follows a cycle of 2, 4 to the power 873 by 2, we will always get remainder as 1 because this is an odd number. So we can say that 4 to the power 1, which means the first term of the cycle, is 4, or 4 to the power is 4, hence 4 is the answer. Now let's see cycle of 9. So we know that 9 to power 1 is 9, 9 square is 81, so 1, 9 cube is 81 into 9, so the last digit will come as 9, 9 to power 4 is 9 into 9, the last digit is 9, so 9 into 9 is 81, so last digit will come as 9, and so on. So we see that 9 also follows the cycle of 2, and the digits of the cycle are 9 and 1. So we can say cycle of 2 and the digits are 9 and 1. Similarly, if we observe the pattern, 9 to the power odd is always 9 and 9 to power even is always 1. So we can also say that 9 to power odd will always be 9 and 9 to power even will always be 1. Let's take few example. 389 to the power 285. What will be the value at its units place? So we can also write it as 9 to the power 285 by 2. Since it is an odd number, the remainder will always be 1. That means 9 to the power 1. So first digit of the cycle, which is 9, or 9 to the power 1 is 9, as we know. Alternatively, we can say that 9 to power odd is always 9. Hence, the value at the unit digit is 9. Let's take one other example. 489 to the power 236. What will be the answer? Straight away we can say 1. Now let's see cycle of 5. So 5 to power 1 is 5. 5 to power 2 is 25. So again 5. 5 to power 3 is 125. So again 5, and so on. So we know that any number that is ending with 5 with power of n will always have 5 at its units place. So can you write it? Any number where the value is, say, x, 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 and its units place it is 5 to the power n equals 5, or we can say m 5 to power n equals 5. Similarly, let's see cycle of 6. 6 to power 1 is 6. 6 square is 36. So again 6. 6 cube is 36 into 6. So 6 into 6 is again 36. So unit digit is 6, and so on. So similarly, for any given number where the digit at the units place is 6, the power of anything, the value will always be 6 at the units place, right? So any number ending with 6 having any power will always have 6 at its units place. Let's see cycle of 7. Now we know that 7 to power 1 is 7. 7 square is 49. So we take 9. 7 cube. 9 into 7, 63. So we take 3. Sorry, 7 to power 4 is 3 multiplied by 7, 21. So we take 1. 7 to power 5 is again 7. 7 to power 6 is again 9, and so on. So we see that 7 also follows a cycle of 4. So can we write 7 also follows cycle of 4, and the digits are 7, 9, 3 and 1. Let us take a few examples. 7 to power 105. Now we know that 7 follows the cycle of 4. So can we write 7 to power 105 by 4. Now we know the divisibility rule of 4. Last two digits must be divisible by 4. Here in this case the remainder is 1. So we can write it as 7 to power 1, which is first term of the cycle. Hence 7 is the value of the units. place. Let's take another example, 7 to power 92. Now 7 to power 92 by 4, remainder is 0. So remainder is 0 means the last term of the cycle. So last term of the cycle is 1. So we can also write it as, if the remainder is 0, we can also write it as 7 to the power 4. If you don't remember 7 to the power 4, you can also write it as 7 square into 7 square. So the last term is 9 and here last term is 9. So 9 into 9, the last term is 1. And since the remainder was 0, we can also say that the last term of the cycle is 1. Hence 1 is the answer. Now cycle of 8. 8 to the power 1 is 8. 8 square 64, we get 4. 8 cube, 8 into 4 32, we can write 2. 8 to power 4, 2 into 8 again 16. 8 to power 5, so 6 into 8 is 48. 8 to power 6, again 8 into 4 is that 8 into 8 is 64, so 4. 8 to power 7 is 7 into 8 is 32, hence 2, and so on. So we see here that 8 also follows the cycle of 4, and the dates are 8, 4, 2 and 6. So we can say that 8 follows cycle of 4 and the digits are 8, 4, 2 and 6. Now let us take one example, 8 to power 584. So how we can write this? 8 to power 584 divided by 4, since it follows a cycle of 4, we get remainder as 0. Last two digits is completely divisible by 4. Hence, remainder 0 does not mean first term of the cycle. Remainder 0 always means last term of the cycle. So we can say 6 is the answer, right? If you don't remember, you can also write it as last term of the cycle. So last term of the cycle can also be written as, since it follows the cyclicity of 4, 8 to the power 4, which can be written as 8 square into 8 square. Now we know that 8 square is 64, so 4 into 4. Now 4 into 4 is 16, hence the units place is 6. Now say you have given another number 218 to the power 123890000. What will be the value of this expression at its units place? So we can write it as, we know that the last two digits is completely divisible by 4 since it is 0. So the last term of the cycle, is 8 to the power 4. So last term is 6 and 8 to the power 4 we already know. The units place is 6. Let us take another example. 588 to the power 12345. Now let's divide the last two digits by 4. So we get remainder as 1. So we can write it as 8 to the power 1. That means first digit of the cycle, which is 8, and 8 to the power 1 is 8, hence 8 is the answer. Let's take one final example. 698 to the power 2347. Now we know that if we divide this by 4, we get 8 to the power 3. Now if you don't remember the digits of the cycle, you can also write it as 8 square into 8 to power 1. So 8 square is 64, so 4 and 8 to the power is 8. So 8 for the 32, so 2 is the answer. So to summarize, we can say that 2 to the power n, 3 to power n, 7 to power n, and 8 to power n follows a cycle of 4. Please remember this. And 4 to power n and 9 to power n follows a cycle of 2. Also, they follow odd and even power funda, right? And cycle of 1, 5, and 6. They follow cycle of 1, which means the units place will always be the number itself. So just remember 2, 3, 7 and 8 follows a cycle of 4, while 4 and 9 follows a cycle of 2. Okay. Now let us see some findings. Some findings. Say for example, 2 to the power 1 was 2, 2 square was 4, 2 to the power 3 was 8, 2 to the power 4 was units place was 6, and 8 to power 1 was 8, 8 to power 2 was 4, 8 to power 3 was 2, and 8 to power 4 was 6. These are the cycles basically. Now see here, if we add 2 to the power 1 and 8 to the power 1, we get 10, right? That means the unit place is 0. Similarly, if we add 2 to the power 3 and 8 to the power 3, we get the summation value as 10, which means the unit place is 0, right? So can we write it as 2 to the power n plus 8 to power n? The unit place will always be 0 if n is odd. So if someone gives you a question like this, 2 to the power 263 plus 8 to power 263. So we can say the value will be 0. Again, let's take an example. 2 to the power 145 plus 8 to power 145. The value of n is 145, which is odd. So straight away we can say the value of the unit place will be 0 because our n is odd. Similarly, we can see 3 to power 1 equals 3, 3 square 9, 3 to power 3 we get 7 at unit place, 3 to power 4 we get 1 at unit place. Similarly, 7 to power 1 is 7, 7 to power 2 is 9, 7 to power 3 is 9 7 is 63, so 3, 7 to power 4 is 7 into 3, so units place 1. Again we can see this pattern, 7 plus 3 plus 7 is 10, so units place it is 0. Similarly, for this as well. Hence we can say that 3 to power n plus 7 to power n equals 0 if n is odd. Now let us see one more. 4 to power 1 is 4, 4 to power 2 is 6, 4 to power 3 is again 4, 4 to power 4 is again 6. Similarly, 6 to power 1 is 6, we know. 6 to power 2 is again 6, 6 to power 3 is again 6, 6 to power 4 is again 6. If we see this, 4 to power 3 and 6 to power 3, we get 4 plus 6, which is 10. If we see this, 4 to power 1 and 6 to power 1, we get 4 plus 6, which is again 10. That means the value of the unit place is 0. So we can write it like this again, 4 to the power n plus 6 to power n. The value of the unit place is 0 if n is odd, right? Similarly, we can see for 1 and 9. So if we write like this, 1, 2, 3, 4, 5, 6, 7, 8 and 9. 4 and 6 makes 10. 7 and 3 makes 10. 2 and 8 makes 10. And 1 and 9 makes 10. Right? So can we write like this? 1 to power n plus 9 to power n equals 0 if n is odd. Similarly, 2 to power n plus 8 to power n, the unit digit will always be 0 if n is odd. 3 to power n plus 7 to power n equals 0 if n is odd, and 4 to power n plus 6 to power n equals 0 if n is odd. Now let us come to our very first question. Right? Find the value of the expression at its unit place. Right? So the question given is 982 to the power 787 multiplied by 233 to the power 140, 547 to the power 700, 78 to the power 264 multiplied by 825 to the power 555. Right? So we have nothing to do with digits at other place. We only need digits at unit place, right? So this we eliminate. So we can write this question again as 2 to the power 787 multiplied by 3 to the power 140 multiplied by 7 to power 700 multiplied by 8 to power 264 multiplied by 5 to power 555. Now we know that the cyclicity of 2 is 4. So we can write it divided by 4. Cyclicity of 3 is also 4, so we can divide it by 4. Cyclicity of 7 is also 4, so we can divide it by 4. Cyclicity of 8 is also 4, so divided by 4. And cyclicity of 5 is 1. So the value will always be 5. So we can write it as, now if we divide last two digit, we get 87 divided by 4. We get remainder as 3. So we can write it as 2 to the power 3 multiplied by 140. Last two digits completely divisible by 4. Hence the last term of the cycle. So cycle of 4. So we can write it as 3 to the power 4. Again, last two digit is 0. Hence it is completely divisible by 4. Hence the last term of the cycle. So the last term of the cycle can be written as 7 to the power 4. 64 is completely divisible by 4. Hence again the last term of the cycle, hence it can be written as 8 to the power 4, and this we can write it as 5 to the power 1. Now we know that 2 to the power 3 is 8, 3 to the power 4 is 3 3 is 9, and 9 9 is 81, so 1. Or we can also take the last term of the cycle. So the last term of the cycle for 3 is 1, so 1 into last term of the cycle of 7, which is again 1, or 7 square into 7 square, so 9 9 is 81, so 1. Now last term of the cycle of 8, so we get 6, or we can also write it as 8 square into 8 square, so 8 square is 64, so 64 into 64, that is 4 into 4, that is 16, hence 6 into 5. So let us see what is the value. So we can write it as 6 5s are 30. Now the last digit is 0. So anything multiplied by 0 is 0. So the last term of this expression is 0. Hence our option is option A. Now suppose this question would have been changed. Okay, instead of multiplication, it would have been addition, which means 982 to the power 787 plus 233 to the power 140 plus 554 to the power 700 plus 78 to the power 264 plus 825 to the power 555. If it would have been plus, how our answer would have differed? So till here the process would have been same. Here we did multiplication, but if this would have been addition, only thing we would have done is 8 plus 1 plus 1 plus 6 plus 5, right? 10. So the last digit is 0 plus 6, last digit is 6 plus 5, 11. So last digit is 1. So the last digit of the expression would have been 1 if this expression would have been addition. Okay, hope this is clear. In the next episode, we will see some application of cyclicity. Thank you.